My name is Ritesh. I work with Singapore Airlines and I'm an agile consultant and a part-time developer with them. And I'm accompanied by Noorul.
Hi, I'm Noorul. I work as a front-end development lead in Credit Suisse. My area of interest are progressive web applications and micro-frontends. Thank you.
Lovely, thanks. And we here co-organize a meetup here in Singapore. It's a collaborative dev and technology enthusiast group. We just try to do meetup events every month on different topics that technology enthusiasts might be interested in and would like to explore. So you're welcome to join. And we have an upcoming event on nodeless architecture on public clouds. This is happening on 10th of June. So I hope to see some of you there, and in fact all of you there. But have you guys taken any geek fees as yet? Oh, were you not in the opening keynotes? Oh, that's a shame. No geek fees? You could win a drone today if you take a selfie. Show us the geeky side and then it's there for you. So take selfies, go around, show us the geekiness, and that's there. Anyways, back to the agenda of today. It's pretty simple. We are going to talk about micro frontends, what are micro frontends, the need of micro frontends, if they really make sense to us, the micro frontend patterns, and the best practices, goods, bads, whatsoever. To start with, is this a new term? How many of you are familiar with micro frontends? If I could. Lovely. Great. So yeah, that's good to see. So a few of us, but for most of us who are sort of not aware, right? So we do the easiest thing that we as geeks do. We go to almighty Google and ask Google, what is a micro frontend? Okay, and that's what it shows us. I think this side would be better. I don't know if you could catch the view. It's a bit odd. Right, so what Google tells us about micro frontends, it says the term micro frontend first came up in ThoughtWorks Technology Radar at the end of 2016. I think the Technology Radar is some kind of an half-yearly report that ThoughtWorks publishes for the latest trends in technologies. I think they are giving away a copy here in case you guys want to collect. And then they say it extends the concept of microservices to the front-end world. Now that's curious. So they are saying that you think about microservices and extend the same concept to the front end. So if we just try to sort of think through what can we relate, what are the terms that you could relate with microservices, and some terms that would come over in your head: independent, scalable, autonomous, specific team, feature rich, and so on. So does that mean that the micro front end is something that could extend the same thing, and micro front end becomes independent, it becomes feature rich, it is something that is independently deployable, it is something that is scalable? Does it really mean that? Well, we could sort of speculate on that. There are ways to sort of look at it, but in general, it is saying that when you are able to separate, and if you can independently manage a front end or user interface. Okay, let's go with that general definition. But how does it relate to us? Does it really matter? Should we care? If there are microservices, do we really need to worry about micro front end, and how does this whole picture add up? If we have to explore it further, we need to probably look a bit into the architecture, right? So we understand that microservice is an architectural style, and micro frontend extends that, so it's probably an extendable architectural style. But what does it really mean? So let's give it a minute, go one step back and talk about architecture. What does it really mean when we talk about software architecture, right? So if suppose the person sitting next to you asks you, hey, why don't you tell me about your software architecture? What would you say? You may probably think a bit, you will give it a serious thought, and probably after a while you will say, who are you? right? But okay, any which ways, when you give it a serious thought that what your software architecture are, in your own head, what you will try to do is probably think over the different features, components that you're in, and you will probably decompose it into multiple components and try to establish a relationship between those components. And as you sort of do that, you somehow express that architecture in one way or the other. What we see here is the different perceptions that people draw from architecture. It is extracted from a white paper that was published by Philip Crutchen and is expressed in the book Microservices Patterns. What is essentially talk about is, as you perceive the software architecture, it could be probably in from one of these four views. We could talk about the logical view as we developers sort of can understand it. We talk about classes, we talk about packages, we talk about modules, and we talk about the relationship between them, how the workflow essentially would happen. We could look at from the implementation view perspective, which talks about once you build it, what is extracted? Is it a jar? Is it a WAR file? Is it an executable jar? Is it an executable file? Is it a minified JavaScript or whatsoever? There is another view of that, of the process view. When we think about the process, once you have put that binary or whatsoever in an environment that it runs into, what does it look like? It's a process. And then there are processes which would be intercommunicating, talking with each other, probably executing a job and interacting through probably IPCs. And there is another view of deployment. How are these deployment orchestrated? Is it on one server or multiple servers involved? How the communication happens? Is there a network, the kind of network, and whatsoever? When you look at from different perspective and you put it all together, you define an architecture in one way or the other. Then there is one more aspect, which is of people. People who are working in those architectures or who probably define and design the architectures and their communication structure, how they essentially end up working together. When we talk about, say, software requirements, right, for which we develop the architecture or sort of work on, there are two aspects of it again, a functional and a quality aspect. Functional is when we sort of think about the business needs that the software would essentially be solving. And then there is an aspect of quality or utilities as is commonly known. We talk about maintainability, we talk about scalability, we talk about extendability, quality, we talk about deployability, reliability, security. And when we are working in an agile environment where you are probably releasing very frequently, we also talk about ability, which is probably turning out to be the most important these days. Coming back to architecture and the micro frontends, so where does it fit in all that picture? This is another favorite or probably a popular picture that you would see in your almighty Google searches. What we see here is a traditional layered architecture where you have a presentation layer, a business domain, persistence, and infrastructure as it's commonly known. The big block that you see here represents something that is commonly known as monolith. In literal term, monolith is a single big piece of rock out of which you sort of carve it and make something really beautiful. What it essentially means, if you think in the logical terms, when we talk about classes, packages, libraries, and whatsoever, they are all essentially part of one package. And when we think from an implementation perspective, we see that it's just one process that contains that whole application. So whatever the application needs is essentially a part of this application. Next to it, as we go from left to right, we see something that is a microservice architecture, where we see that the business domain is essentially segregated and decomposed into individual features, and it's feature rich, and it appears to be independently manageable, deployable with individual teams taking care with full autonomy of this. And then you have an aggregation layer on top of it that probably puts these things in a meaningful way that could be consumed by its users. On the top that we see is something that relates to the user interface. Now, user interface is something that has grown over a period of time, and it has become much more meaningful and interactive than what it was probably a couple of decades back. It has much more user interaction, you see much more things, you could play a lot with it, you play games, you do things, and it's much more interactive. The user interface is something that is extending, and then we are more and more exploring and focusing on user experience and how interfaces enrich experience. So when we put these things together, what this still looks like from a microservice architecture, which is really focused on extracting and segregating the business logic, one area that we are still not touching is what happens to the front end, and if the front end has to be feature rich, how it could be made. Because currently it looks like it's still the same big piece of rock as in Monolith. Micro-frontend is something that says if you have a feature-rich architecture that covers your front end, business logic, and the persistence, and anything that has to do with that feature is looks and is managed by one team, is one layer of thing, is probably a one micro-frontend service. It might seem a bit confusing to think about micro-frontend is just about front-end. It is something I would emphasize is to do with front-end, back-end, and the business logic all together with one team focusing on it dedicatedly. To sort of suggest further, I will probably take you through our experiences. So me and my friend Noorul was working on one application a while back, and we have a few experiences to share as to how we sort of explored the issues that we faced, and we explored micro-frontend architecture and what our results were. So let me take you there. A few years back, we started working on a small application that was loosely based on some kind of an inventory management, but it is something to do with looking at the shelf life of it, a reporting thing that sort of goes back, generates some reports, displays the user interface in front. We had a small use case, we did it brilliantly, 3-4 guys, and it was sort of pretty good. We had continuous build, continuous deployment, everything in place, and life was really good. We had a small use case, some less than 300 unit test cases, good number of integration test cases, build, packaging, all automated, done and dusted, released to production, everything looks essentially fine. And it was well appreciated by the customers. Over a period of time, the customers realized, and we were happy to accommodate certain requests that were to do with making it more feature rich, have more abilities, have more interaction with them. Initially, life was good. With Monolith, it was quick development, everything is controlled, straightforward testing, straightforward deployment. I don't have to care about a lot of packages, and it's easy to scale. Okay, just replicate it. It's a small application, what does it take? As it sort of grew over a period of time, what we realized was that we need some more right tools to cater to the requirements that are there on the front end. And we thought that we probably need to have more specialization and more dedicated tools so that our code remains structured and maintainable. So we added, and rather than just being what we were earlier doing was just some free market templates and using the structs and having a web server running and playing with it. Then we extended it to some front-end architecture. We created a Node.js bag with jQuery, Backbone, some bootstrap for styling, and our test cases extended to Jasmine and so on in the front-end structure. It was sort of still good. We scaled it. It sort of works well, but as you see here, it was still that one package that we had that we were just making, building it, releasing it, and so on. Bit of glitches, our build and packaging time increased from what was earlier 5 minutes to 15 minutes, but we did not see it as a bad signal. I said, okay, let's sort of go on and see how it goes. Our teams expanded as we were specialized in back ends and front ends. So there were two parts that happened over a period of time to the team. So there is a front end team that is dedicated to all the front end stuff, and the back end teams who are specializing in the services that they were developing. Then it just blew up. A couple of years later, we were pretty heavy on our technology stack. What you see here, we got pretty heavy on the front end. As new technologies came in and we were exploring, we had React, jQuery, Backbone, Bootstrap, Enzyme, a lot of third-party libraries which were to do with all the kind of the work that we wanted. You need something, you need a table, download it, just have a React sort of incompatible library. You could have date pickers, I could have combo boxes, beautiful looking, I could have toggle boxes, and everything is added, and it still worked well. But the thing was that we realized that as we work in a regular release cadence, we were spending a lot of effort in maintaining that code. A lot of effort went in testing that. Writing the test case was no longer easier. Executing and building a package, what was 5 minutes in our early days, turned out to be 1 day. Our tests were flaky, highly unreliable. It would take a couple of hours to sort of just go through and run the integration test. And that really impacted our morale as to why are we even doing that? We had just messed up this thing. And we were like totally agitated, angry with ourselves. There were some really hard challenges that we were facing at that point in time, which I have summarized here. It was getting really hard to maintain code because it has become a mammoth. This is something that we commonly relate with the monolith. Right? It's really hard to maintain. We don't know essentially what to do. You essentially write a code and say, okay, what am I going to do next? We essentially need to write tests first, right? Yeah, we essentially write tests first. Oh, but it's hard to write tests first. It's not very easy. We don't know what essentially is going wrong. We have a technology stack that was getting obsolete. We were probably started with React 12 or something, and a lot of third-party libraries that were being used at that point in time. And interestingly, those third-party libraries were never updated, but we were stuck with them. If you want to move with the latest version of React, it's not that easy to do. You are stuck in a monolithic hell that you have to deal with the technology stack that is obsolete. The code gets hard to read, it's hard to maintain, and it's not easy to write test cases because we also had a lot of God classes developed. Familiar term, God classes? Yeah? Okay. If it's not familiar, it's something, God is something who does everything. Your utility, your common classes, everything is in one place. Don't know where this thing will go. You have a God class, it will take care of everything that you essentially need. And functionality were overflowing from one piece to another one. There was probably no boundaries of what essentially would be in front end, what in back end. Don't know, okay, probably this is not my role, probably it should rather be at the front end. And it sort of an overflows. The business domain overflows to different layers, and it gets really hard to sort of understand. Any new developer walks in, come on, this is a hard project to sort of deal with. We saw a lot of developers that were in our distributed team that was in multiple places, some in Europe, some in India, and we in Singapore. We were sort of specialized in our own holes of things, hardly used to talk to each other and understand, okay, this is my work, I do this, and I'm happy, let me go home. You break the build, okay, you fix it, till the time I'm not doing anything. Yeah, our collaboration sucked. Scalability was essentially a problem. So we worked in we called it an agile environment, but it wasn't really. You would sort of pick things, and you could sort of imagine that if you are working in an environment where you say, okay, estimate what would this likely take. Maybe it will take 1 day. Oh, but I also have to write test cases. Let us make it 3 days. It's a good indicator there is something terribly wrong. Because if the maintenance, changing your project and to sort of really stray true to your values takes you that much of an effort, there is something really wrong with the architecture that we are talking about. Our code was of course tightly coupled. We had these God classes, testability was hard, and our release cadence was getting longer and longer. Our productions build failing and so on, and you know the rest of the story. We were of course highly demotivated, but we noticed one thing. We were highly motivated when we were doing hackathons. Something new is better. I don't want to work on that project, do whatever you want to do. I want to participate in hackathon because I can show my skills there. I could do whatever I cannot do in this application, I can go and do it there. I want to play with the new technology. I hear there is a new context API in React that is pretty cool. Can it replace Redux? No clue. Let me sort of test. But there is a project I could do that. How is the latest Angular version? We cannot do in this project, it's pretty hard, can't explore it. Those were the general talk. Right or wrong architectural decision, that's a different thing. But yeah, as developers, we like to explore new things, right? And if you don't get an opportunity, you are rather a bit demotivated. Any which ways, so we thought there was an opportunity for us to sort of redo that thing. But it's not easy to refactor a monolith that we were dealing with. How do you sort of deal with such a thing that takes really hard to even make a small change? Micro-frontend we thought would help us. The concept looked promising and we explored it. It essentially helped us modularize and separate our front end and link it rightfully through the back end through certain patterns that we applied. How we did it is something that we'll see in the next section. But we did apply certain strategies that essentially help us. The most common that I assume most of you might be aware of is commonly known as Strangler. Is it a new term to anybody? Everyone knows it. All right, lovely. I'll just reiterate. So it was, if you go on and try to refactor a whole monolith, it would take you ages. You would grow old. Your kids will forget you. Nobody would sort of look at you. You won't go home, and you will be in a deep mess. Because it's even not something that needs to be done. You cannot refactor a monolith. When you're doing it, you're essentially probably just rewriting it. Refactoring is something that you are doing some small change when it comes. So there is essentially some change request that you are probably dealing with. There's a new feature you're working with. Take that one small step. Probably we thought we'll just take that, move a little bit forward, see what are the related things that we could sort of impact, and separate it, make one small module out of that, and sequentially, one point at a time, try to refactor it, reduce the size of a monolith and look more from and develop multiple micro frontends and see. And it essentially worked well for us. At that point in time, we were able to segregate based on the business domain, divide into subdomains within giving their own bounded context. And we thought we had a bit of a success with that. But do I recommend micro frontends? Well, it's not that straightforward. It really depends on your own use case and how do you see it. One thing that I can surely recommend is to see the systems as you sort of define it. So when someone sitting next to you asks you what is your software architecture, if you're able to tell them in the business domain, divide it by the business domain, and then express it in the subdomains and the relations that they establish with each other, yes, I think we'll be in a much better position. Now, some benefits that we saw with the micro-frontend architecture as we move forward, it became better. I won't say it solved all our problems. There are still many problems, but yes, whatever we were developing new, it was small and easy to maintain, just like the first thing that we did. It was independently deployable, so we were happy, yes, because we could sort of ensure our progress. We can be confident and happy about it. It was independently scalable. It enabled teams to be autonomous, so we know that we have a front-to-back responsibility and we are happy, we take the full ownership of it. The technology adoption became easier. We were able to experiment with technologies which we thought are strategic and probably we want to take it forward and could still combine and work together. Better fault isolation, something that sort of goes wrong can just be sort of disabled and sort of the rest of the thing would still work and won't bring down your whole application. And the most importantly, the team essentially is able to bond. They are not stressed out. They can just work independently. They just know their business domain. And yes, they were in a position to express what their business domain was when asked, what is your software architecture? So that's about what happened then. How it happened, for that I would like to invite Noorul to come and share how it happened.
Thank you, Ritesh. Ritesh has beautifully covered what are micro frontends and why do we need them. Hope you all convinced that you want to implement micro frontends now, and let's dive into the code. How? The implementation patterns. So we are going to cover these 4 major categories. The first 3 are client-side frameworks, web components, iframes, and components frameworks like React, Angular, or Vue. Using that, you can build micro frontends. The last one we are not going to touch in detail is server-side rendering. So similar to doing the micro frontends on the client side, you can build the micro frontends on the server side. So there is a dedicated talk today at 3:30 p.m. I would highly encourage all of you to attend that to get the in-depth understanding and the full picture of micro frontends. Okay, so we are going to cover one by one. So we are going to spend some more time on web components. That's our favorite, and that solves most of the front-end challenges. Okay, so let's imagine a world without web components. This is how you supposedly will implement. So you have a parent app, and then you have 2 child app, and the parent application will have its own style, and then it will have own scripts, JavaScript, executing it. And by the nature of the web, the styles are global. So I'm sure every one of you must have faced this problem. What the hell is happening here? So why my styles are not applied? Why my color is different, even though I specify this color? So I think every front-end developer might have faced this, and then very difficult to debug and find out what's really happening here, and because of style sheet cascading and the global nature of the DOM. And similar to the script, so the parent application can execute a script. In the web application, since you have a single DOM, any script you can execute, it can get the element access to the child application, and then it can really modify the things. There is no kind of a protection or encapsulation there in the front-end world. So that's a problem. So now let's see a world with web components and shadow DOM. So this is the ideal world. So you have the parent application, you have styles, scripts, and you have child application which are completely insulated and protected from the parent. And there is no parent style coming into the child application, and the document object model, which is an in-memory object representation of your website, you can programmatically change. So that is isolated within the child application. So this is the ideal world. So previously there are lots of talks about web components, and then not all major vendors or browser vendors are adapting it, but now is the right time. Most of the major browser vendors are supporting web components, and you can readily use it from today. So there are 2 important aspects to web components. One is custom elements and shadow DOM. So we are going to see in depth of those 2. What is custom element? Any idea? People have heard about web components, custom elements. Anybody heard it before? Okay. So don't worry, I'm going to start from the basics, so it should be clear. You should be able to follow me. Custom elements enables you to create your own HTML tag. So you have buttons, inputs, all the predefined tags. Now you can create your own HTML tag. Let's say I want to create a search box, which I want to use it as a separate HTML tag. So it will be very simple. I'm not going to add any new functionality. I'm just going to reuse the input box and then just put a little placeholder text there. So first, let's see, we are using the ES6 syntax, class my search extends HTML element, and here, and you have a constructor and you have some of the lifecycle methods. Don't worry about this here. Let's go to the last line, custom elements dot define my hyphen search, and you are specifying this class name. If your browser supports custom elements, these custom elements will be available in your browser. So and then you are defining a new HTML tag called my hyphen search, and then you are associating this class with it. That's it. Once this script executes, you can use this new tag, which is my search, in your HTML. Awesome. Okay, let's look at the code a little bit. This doesn't do much. The constructor, I'm setting the inner HTML, it's an input, putting some styles and the placeholder. This is how it looks in the browser. So you have this search box, and this is the Chrome developer console, how it looks. So this tag appears here. Under body, you have a my search, and you have this input here. That's it. So now you are able to create your own HTML elements, and you can just register it once and use it as many times as you want. Perfect, all good. But custom element doesn't solve the actual problem of global styles and single DOM. Even you use custom elements, still the parent application styles will come into a child app, will mess it with you. And then let's say you are deploying a child application and suddenly the parent application changes, a whole alignment changes, which is what we want. Don't worry. So there is another aspect of it for web components, which is custom elements with Shadow DOM. So we are going to see what it is. Shadow DOM, if you create a custom elements with Shadow DOM, you can achieve both. You have a custom element and also you can have a full encapsulation. The styles will not leak into a child application. At the same time, the parent scripts cannot access your child elements. So these are the two important things: isolated DOM and scoped CSS. This is how it looks like, the tree structure. So this is the parent. This is the parent application DOM, and then the shadow host. For example, you can just think of it as a my-search, which we just created here, and whatever is inside that, the input box and everything, whatever you put it inside, that is completely insulated from the parent application. So the styles and the document elements, everything is fully insulated. But when I say fully insulated, it's not 100% true. If you want, you can still access those elements which are inside the child application. So for example, let's say this is from parent application, document.query selector. You are selecting an element which is inside the child, it will return null. This is as expected. But if you really want to access this for some reason, so you can still do it. What you can do is get access to the host. Host is here, which is my-search. First you get access to the host, and then the host has a property called shadow root, and through that you can select the element inside. So definitely this is a flexible way for that you can access the child element, but by default or by mistake nobody can access the child elements. They have to intentionally do it. So let's modify the my-search custom element to attach a shadow DOM to it so that you get a full encapsulation. So there's two lines I added here. This dot attach shadow mode equal to open. Don't worry about this mode, I will explain later. So I'm just attaching a shadow to this my-search, and then look at the last line, shadow root dot append child search container. Previously this input box is there without shadow root. Now I'm appending this input box to the shadow root. So that's a minor change. Everything else remains the same. Custom elements are defined. This is how it looks in the Chrome developer console. Same like before, my-search, and below that you see shadow root. Whenever you see shadow root, you can assume that everything is fully insulated. The styles will not leak outside, or the parent style will not come inside, and the scripts cannot directly access the elements inside the shadow root. As you can see, the style, I have a CSS class called search, which is used to style this input box. That's it, and this class is not accessible outside, so it's only accessible inside this DOM. This is what the web development community has been looking for a long time. So the full encapsulation to avoid the global nature of the web. Finally it's there, all the major browser vendors supports it. So now it's a good time to implement micro-frontends using the web components. Let's see a demo. For this talk, I created a small application, a shopping portal, which has one parent application and 3 child application, all interacting together and all developed as a web component. And behind the scenes, I'm using React. Okay. Let's see the demo. Okay. The search box is one child application, so you can search for a product and the search suggestion appears. Everything is part of one application which is independently developed and deployed. You search, on the left hand side you see the list of products. That's a one independent application deployed separately. On the right hand side you see the recommendations for that product. Yep. So you're searching. Yep. So let's look at the browser console, the DOM. Okay. You have 3 custom elements. One is Amaze search, which takes care of the search on the top, and you have another one, recommendations, which is on the right side, and then you have a products, which is on the left side. So 3 independent application combined together in the front end to form one single application, while still maintaining the styles scope and the document elements, DOM elements. All good? Happy? So let's dive into the code. So this is the parent application HTML, very simple, nothing fancy. So you just see, we just included 3 script tags, each to download the child application. This search bundle.js is the code for your search application, and products is for products and recommendations. So I haven't specified the actual server name because I'm using a reverse proxy, so that all the request goes to the parent application, and parent application sees it starts with search and it redirects to the server of the search application wherever it's deployed, similar to products and recommendation. So that's it, very simple on the parent application side. For the parent application, I'm using React and just a simple one. So I'm just using grid for the alignment, and I'm just using this 3 custom elements. You go here, once these scripts are downloaded and registers the custom elements, you are free to use it as it is a regular HTML element. So even the React, it doesn't throw any error. You can just simply use it as it is with the button or input. The whole application is inside this, and you can still pass properties and everything is the same HTML syntax. You don't need to reinvent way of communication. You can still use the browser DOM to communicate. Okay. So now we have seen the parent application, the HTML, and the top level component. So let's see a child application. So a child application is also developed using React instead of exposing the React component. So we are wrapping the React inside a web component and then deploying it, so that the parent application, when it consumes, it's a platform and framework agnostic component. The parent application doesn't see it's a React or Angular. For parent application, it's just a web component, which is a standard WT web standard. So let's see. So this is the child application for recommendations you have seen on the right hand side. So this is the one line. Normally your React application will have React DOM.render, and you are rendering the whole application inside a DOM container div element. Now we are going to wrap this inside a web component. Similar syntax, class recommendation extends HTML element, and you can look at the right hand side. This is how the console looks like. So inside recommendation you have a shadow root. So I have added a code, this.attach shadow mode open, and within that we have some container and you have a style sheet. So I'm just creating a tag for importing the style sheet. So when I deploy this child application, I deploy 2 files. One is the JavaScript and one is the styles. So when we register this web component, it knows where to get the style sheets. So you can change this URL and then you can get the web styles and then append this style tag so that it comes here. So this style sheet is fully insulated within this recommendations. It will not leak outside. And then you are appending the app root. So app is here. So everything is inside. The whole DOM elements are inside. The styles are here. Everything is fully encapsulated and protected. And then you are exposing this as a web component. Custom elements are defined. Image recommendation. Once parents download the script and executes it, this tag is available, and then you can free to use as it is a regular HTML element. So now look at the pros and cons of web components. As everyone knows now, the web components are good for scoped CSS. You will not face any conflicts. Isolated shadow DOM. All the DOM elements inside is fully isolated from the parent one. You cannot directly access it until you do it intentionally. and use DOM as your API for communication. So this is really good. Instead of reinventing using pubs and all these things to communicate, you are just using a HTML tag. So you can pass the attributes, and then you can pass the callback and everything, and then the child element can receive it and then act on it. And also the child app can raise an HTML custom event. Let's say search clicked, and then the parent application can catch it and then do the changes whatever it's needed. That's how all these things communicates. And it's framework agnostic. So I just use React. You can use plain JavaScript for web components, or you can use Angular, React, and Vue. And one good thing is, I think, yeah, so we can see in the cons. What are the cons of web components? Mostly web components are good, but the standard has taken a lot of time to materialize and browser vendors to implement. There is one issue, the React compatibility with web components. There is a website called customelementseverywhere.com. So it has all the test cases, and it runs against all the frameworks, and then it reports the pause percentage. So why React is not 100% compatible with web components is React uses the own synthetic event system by default. So the event wire-up will not work. Don't worry. There is a workaround. I just need to use this React Shadow DOM retarget events library, and then all the event handling will be wired up. But ideally, definitely we want the actual fix to be available in the React library instead of using workarounds. The issue is already reported to React team, and hopefully they will fix it soon. For Angular and Vue, it's 100% compliant with web components. And another one, browser support. So as I said, it recently got materialized and all the browser vendors started implementing it. So one thing is Microsoft Edge doesn't support web components as of now. But the good news is Edge is moving towards Chromium based Edge, which is available in the developer build. So that version supports web components. Hopefully once the Chromium based Edge comes to the market, which is already available for developers version, it will fully support web components. So this is the browser support. So as you can see, the Edge 75, which is Chromium based version, it already supports it. Firefox supports it, Chrome supports it, and Safari supports it. Okay, all good? Okay, let's move on to the next one, iframes. Hope everybody heard about iframes, have used it in the past. So I'm not going to spend more time here. But yeah, iframes are meant to embed application within an application. So you just specify the source URL of your child application, and everything is insulated within this iframe. All good, right? So whatever we can do in web components, we can do it in the same in iframe for a long time back. So what's the problem with iframe? Pros: widely supported and battle tested. All browser supports iframe. No CSS conflicts. Everything inside the iframe is fully insulated. Separate runtime. All the scripts runs inside the iframes. They don't conflict with each other. And it's also technology agnostic. All the same good things about web components, same applies to the iframe. But the communication between the apps is hard. So that's why the iframe approach is not so popular. So when you want to communicate between different apps, you have to use window.post message, and there are some security concerns. When you send the message, anybody can intercept, and also at the same time, any other site can send you message also. So which involves the cross-site scripting. So that's one thing, and also the UX suffers. Let's say when you create iframe, you specify width and height. If the content of the child app is more, then the scroll bar will appear in the iframes. There are ways to prevent it, workarounds, but it's not a native solution. And also styling the child application from the parent is hard. In web components, you can achieve it. The parent can control the styles if it is designed like that. So the UX experience suffers. And higher memory utilization for iframes than web components. Web components are lightweight. Web components are treated like a normal HTML element inside your parent, but iframe is completely a new application. Okay, so now we are moving into the third approach, which is using the components library like React, Angular, and Vue, and just using those, building the micro apps as a React component or Angular component or Vue component, and using it directly without wrapping them in web components. Okay, so apps are written as components using frameworks like React, and the parent app provides placeholder div for the child app to render. So all the child application elements will be inside that container. And there are two ways you can do it. One is compile time integration and runtime integration. What is compile time integration? So let's say you create this child app as a component, and then you can publish it to npm repository, and then the parent application can consume it at the compile time. So npm install, and then you can use this component in your parent application. And versus runtime, so you don't need to do it as a compile time when the user uses it. You can download the script dynamically, the child app scripts, and then you can render it inside the container. I would highly discourage you to do compile time integration, because any guess why it's not good thing doing it in compile time? It creates a release dependencies. Any new change you make in the child application, let's say you want to make a small change, increase the font size or decrease the font size. So the parent application has to get the new version, and then they also need to deploy it. When it grows, we have lots of micro apps and lots of dependencies. It will become a hell to release an application. So that's why I try to avoid the compile time integration. You can do it the runtime integration. At runtime, you can download the client scripts on demand. Whenever they make the change, it will immediately available to the parent app without even the parent application has to release. And there is a library called single spot, which can help you to avoid the boilerplate. This library is just help you to download the child script and then render it inside the container. And also when the child application goes out of scope, you can remove it. Will help you to remove this application from the parent. So all this code you don't need to write. This library will help you. So let's see a quick demo of this approach. Yep, this is from single spot library. They have a live example, so we can watch it here. So in the top, you have a navigation bar, and you have a tabs of like Angular, Vue, and React. And on the right hand side, you see these are the div containers. The child application will be rendered inside these tags, and I'm clicking Angular here. So this application, the top is built with React and bottom is built with Angular. And here you see after the user clicked Angular, the script gets downloaded. It's a lazy loading, so build3.js, and you see in the Angular thing now you have elements inside. Similar to that, you can go for Vue, and now you have a Vue application inside the React. As you see, the Vue app has elements inside now. Okay, all good. So how to do it? So you just install this library, single spot. So it has two functions, register application and start. The register application, there are three parameters. One, you just give a name for your child app, and second, you give the URL where to get your child application. And the third one tells the library that when your child application should be active. So they will, based on the URL, let's say if the URL contains home or / without anything, then this child application will be active and it will be shown it to the users. For example, let's say the navigation bar, which should always be visible. So you always return true so that it's always visible. For AngularJS, when the user clicks the tab, it will download from this location, and it will be active when the URL contains /AngularJS. And then you just need to start once you register all the child application. So this library will take care of mounting the child application and then unmounting when it's not in use. So that's it. I'm not going in depth on this. You can refer to their website and then look at the documentations. Pros and cons. So it's simple integration for apps using same framework, so you don't need to wrap it inside web components. And if all things uses React or all things uses Angular, then it's easy to integrate and communicate. But the cons is no style encapsulation. You are back to the old problem of CSS conflicts and style cascading to a child app. So you have to do all the things yourself. This library doesn't provide anything. So you have to use something like CSS modules and everything to insulate your styles. So how to communicate between apps if there are in different frameworks like Angular and React? Mostly you have to use browser events and then capture it in the parent side and then communicate back. And as I mentioned before, the compile time integration creates the release dependencies. Even if you're choosing it, go for a runtime integration. Server-side rendering, so we are not going to talk more about it, but just a high level. So these all really available from long time back, the server-side include. So previously we were just getting all the scripts on the client side in the browser and then rendering the child application. You can do the same thing on the server also. So when the client requests a page, when the server about to return the page, the server can go and fetch the HTML from all different servers, the child application, and then combine it together and return it to the client. So how do you do it? The SSI is called server-side includes. In your HTML, you just include this so that before the web server returns it, you can go and it will go and fetch the HTML from this server and then it will return it. So there is another thing available, the ESI edge side include. So it's similar to SSI. Okay, micro front-end best practices. So we have seen 3-4 approaches. So let's see what are the best practices. Have a common style guide or library. So this is a challenge in micro front-end. Let's say now instead of big monolith, you have independent teams developing or working front to back, UI, server side, database, everything together, and we just combine everything together in the front end. The problem it will cause is like the styles, the look and feel has to be consistent across all the application. Nobody will like your web application where the parent application is one color and font and you have a contrasting color and different font sizes in another application. So it's completely no. So before you go with the micro front end approach, make sure that you have a common style guide for your whole landscape. Or also if it will be good if you have a common style sheet library so that every child application can use it so that the look and feel is similar. Reduce the load time by enabling caching and lazy loading. As you see, the micro front-end approach, you have to download the scripts from multiple child applications, so and then you have to render it. So definitely it will take some time when loading it. So now there are lots of things improved. So HTTP2, which will make it really fast to get all the resources. It can reuse a single connection and get multiple resources. So still it's fast, but yeah, you can enable the caching. Let's say if the child application changes, then you need to get a new version. If it doesn't change, there is no release, you don't need to keep fetching every time. So you can cache all those resources and scripts. And also you can use the lazy loading similar to the single spot library. When the user goes and clicks it, only you can download at that time. If the user doesn't use it, you don't need to download it. Reduce the dependencies between teams, don't share runtime. Don't enforce anything like all the child application has to use this version of React or this version of Angular. So give flexibility. So I think all the version can coexist. So this will remove the dependencies and make the team autonomous, and then they can upgrade whenever they want instead of forcing and creating a release dependencies. Use browser API for communicating between apps. Don't try to reinvent the wheel by creating your own PubSub mechanism. So browser APIs are well battle tested, so you can just raise an event and parent can capture it and then act on it. All good. So we are on time. References and credits. So you can go through these websites. So microfrontends.org, which has all the client side micro front end integration using web components. So you can refer to the website. And Google has a very good documentation on web components. And for the single spot demo you have seen, you can use this singlespot.js.org. It will have a very exhaustive documentation on how to use it. That's all. Thank you all for listening, and